Thank you very much, ladies and gentlemen, fellow Kenyans. Good evening. I'm Babu Owino, Member of Parliament, Kcse East constituency, and a teacher for our candidates who are going to sit for the exams this year, that is Kcse examination. Ladies and gentlemen, I would like to tell my students, my viewers, the Muslims, I would like to take this opportunity to wish you Ramadan Kareem and Saum Makbul. To our brothers and sisters who are not in a position to access the internet or to access smartphones or are not in a position to afford airtime, I would like to take this opportunity to apologize on your behalf and say that one day you will make it. Do not give up. Everybody starts from the bottom. And after all, if we started from the bottom, we can never lose. Number two, make sure, comrades, candidates, students, make sure you work hard until you no longer need to introduce yourself. Next, I would like to take this opportunity to wish Kenyans who are experiencing this pandemic, the coronavirus 19, it's been a problem to Kenyans and to the global village. I would like to take this opportunity to tell you to continue adhering, taking precaution so that we can prevent the spread of Corona 2019 or Corona 19. Make sure you don't leave the house, only leave if there's something important that you're going to do. Make sure you put on masks. Make sure you sanitize. Thank you, and I wish you all the best as you'll be enjoying the lesson. Today is chemistry. Our chemistry topic will be proceeding with the previous, from the previous lesson that we had, a topic on organic chemistry. Last time we dealt with alkenes. Today we will deal with alkenes, which is in the homologous series. So today's lesson is still on organic chemistry. And today we will deal with the homologous series still. And we said that homologous series are hydrocarbons that have the same molecular formula, same functional group, but the successive members of the group differ by CH2 group. And today, as part of the homologous series, what we'll deal with is alkenes. So number one, alkenes are long chains. Number two, alkenes have double bonds. Number three, alkenes are presence of the double bonds. And the presence of the double bonds, they occupy or they have less number of hydrogen atoms. That's why they are unsaturated. From here, the first alkene we deal with must be an ethene. Why is it an ethene? Because an ethene has two carbon atoms that have a double bond between the first carbon atom and an adjacent carbon atom. So from here we will go to naming of alkenes. We will go to naming. Let me just start from a fresh page. So naming or the nomenclature. So alkenes have a general formula of CnH2n. So in naming the alkenes, we will just replace the number of n. N represent the number of carbon atoms. So in our situation, if n is equal to 2, we just simply replace it here because we said that the first alkene is an ethene. Therefore, when we replace here, we get C2H. Then when we replace 2 in place of n, it becomes 2 times 2. So this gives you C2H4. So C2H4, this is the molecular formula for ethene. When we want to get the structural formula for ethene, the existence of the double bond, then the hydrogen atoms attached to carbon. So here we have a double bond, then there's a bond here and a bond here. Every carbon atom must have 4 bonds. So this is an ethene. Then when n is 3, we have C3, H, 2 times 3 is 6. So that is C3H6. And then again we can draw its structure. So when we draw it that way, hydrogen atoms attached to it, 1, 2, 3, 4. So this is called a propene. So in naming the alkenes, the prefix eth or ethene, eth is the number of carbon atoms. So if there are 2, they are eth. If there are 3, they are prop. Then in from the parent name alkene, in is the suffix. So you just replace it there. You just put it there as the suffix. Prop is the prefix that represents the number of carbon atoms. Then in comes from the parent name, which is in alkene. So it becomes propene ethene. So when n is 4, you have C4H8. So when n is 4, these are hydrogen atoms. So this is called a butene. But, the number of carbon atoms, then in is the suffix. When n is 5, you get C5H10. So from here, 1, 2, 3, 4, 5. Hydrogen atoms attached. You make sure you clothe it. As I said last time, 1, 2, 3, 4. This will have 2 hydrogen atoms. This also 2 hydrogen atoms. This will have 3 hydrogen atoms. So these are 1, 2, 3, 4, 5. That is a pentene. Pent means 5. Then you take the suffix which is in from the parent name alkene, in. Then when n is 6, that is C6. This is only 1 hydrogen atom because there are 2 bonds here and 1 bond here and another bond. So every carbon must have 4 bonds. So like this carbon has 1, 2, 3, 4 bonds. This has 1, 2, 3, 4. This 1, 2, then 3, then 4. This was 1, 2, 3, 4. So this is from the word hex. Hex means 6, then in, hexene. So in our syllabus, we are required to know the first 6 alkenes. That is ethene, propene, butene, pentene, and hexene. Then from here, we go to isomerism. Isomerism. Class, last time I said that isomers are organic compounds or are hydrocarbons which have the same molecular formula but different structural formulas. Isomers are hydrocarbons or organic compounds with the same molecular formula but different structural formulas. So be keen here, I want us to name the isomers. Number 1, if we have this compound and then we have this compound. Now, in isomerism, we have 2 types of isomerism here. We have positional isomerism and chain isomerism. So 1, we have positional isomerism, and 2, we have chain isomerism. So we will combine the 2 in the process of naming. We will name them as the position of the carbon double bond on the carbon atoms changes. In positional isomerism involves the change in the double bond, the change in the position of the double bond. Then chain isomerism involves the branching of the alkenes. So we will name it, I will just write down the examples, then we name it in form of positional or chain isomerism. So if we have this, then you change the position of the double bond. You form isomers just by changing the position of the double bond. This. So this is out. Don't consider this. This is, you have 1 hydrogen atom there, but the position of the double bond has changed. This is 1, this is 2. Then the third one, if we have this, that hydrogen atoms, make sure it's attached to the carbon. 1, 2, 3. 1, 2, 3, 4. So this is not there. 1, 2, 3, 4. Then 1, 2, 3, 4. These are hydrogen atoms. Then 1, 2, 3, 4. This is not their class. So when we have the 3, how do we name them? The first one, rule number 1, identify the longest continuous carbon chain. The longest continuous carbon chain in our first one is 1, 2, 3, 4. You just count it. 1, 2, 3, 4. So if it is 4, it means it is a bute. Then identify the position of the double bond. The position of the double bond is on the first carbon atom. Then when you're separating the numbers and the letters, the letter, you separate it from a number, you use a hyphen, then 1, the position of the double bond on the first carbon atom. Then a number and a letter, again you separate with a hyphen. Then you just add in from the parent alkene. So this is but1 in. Class, identify the longest continuous chain, that is 1, 2, 3, 4, makes it a but. Then the carbon atom, the double bond is on the first carbon atom, which is here. You write it like that. Then you add in. So it is but1 in. The second one, class, count the number of the carbon atoms on the longest continuous chain. That is 1, 2, 3, 4. So if it is 4, again it is a but. Then identify the position of the double bond. It is on the second carbon atom, 1, 2, hyphen 2. Then just add in. So this compound is but2 in. What about the third one? The same rule applies. Identify the longest continuous chain, 1, 2, 3 or 1, 2, 3. 1, 2, 3 or 1, 2, 3. So if you know that there are 3, you go to prop. The position of the double bond is on the first carbon atom. So it can be prop 1 in. But remember, ethene and propene, they only have one double bond. The position of the double bond can only appear on the first carbon atom. So the position of the double bond appears on the first carbon atom. So there is no need of writing prop 1 in. You can just write it as propene. That only applies on ethene and propene. Then anything else which is not along the longest continuous chain is a branch. Anything else which is not on the longest continuous chain is a branch. So identify that branch. This is where the branch is. This is where the branch is. So class, what type of a branch is this? Number 1, this branch has one carbon atom together with 3 hydrogen atoms less 1 hydrogen atom. So it belongs to an alkyl group. And which type of alkyl group is it? It is a methyl. It is a methyl because methyl has 1 carbon atom, 3 hydrogen atoms less 1 hydrogen atom. So it is a methyl group. Then the branch is on which carbon atom? Identify the branch on which carbon atom? 1, 2. The branch is on the second carbon atom. Therefore, you just join the 3 to form 2-methyl propene. So you can write it as 2-methyl. Then you can use a small letter for this to be propene. That is the first one. Then we can do another example. Another example for the isomerism. If we have this compound, make sure you dress it, you clothe it. And this is 1, this is 2. Now change the position of the double bond to come here. The third one. Now after this, because if you bring this double bond here, it will still be, the double bond will be on the second carbon atom from this side. It is also on the second carbon atom from this side. So you just leave it at that. Then we try to branch them. maintaining the number of carbon atoms. So the number of carbon atoms are still 5, but let's see, we branch them. 1, 2, 3, 4, but we branch from here. What will we get? 1, 2, 3, 4. And again, if we branch another one, we place the position of the double bond here. Then we branch it from here. So that's okay. Suppose we branch again here to get the fifth one. We have this, but we make a branch at this point. This is a double bond. 1, 2, 3, 4. So let's name this class. The first one, very fast, identify the longest continuous chain. 1, 2, 3, 4, 5. So it gives you an idea of a pent. Then the position of the double bond is on the first carbon atom. So you write pent 1, then you just add the suffix in. So it is pent 1 in. Second one, very fast class. Identify the longest continuous chain. 1, 2, 3, 4, 5 is still a pent. But the position of the carbon of the double bond is on the second carbon atom. Therefore, it is pent 2. You just add the suffix in. The third one, class, be very attentive here. Identify the longest continuous carbon chain. 1, 2, 3, 4 or 1, 2, 3. Therefore, we go with the longest, which is 4. So once we know it is 4, we know that it is a but. But the double bond is on the first carbon atom. So it is a but 1 in. Remember, you've just named the longest continuous chain, but there is a branch. Anything which is not on the longest continuous chain is a branch. How do we name this branch? The branch has 1 carbon atom, 3 hydrogen atoms, less 1 hydrogen atom. Therefore, it is a methyl. It is a methyl. Then the branch is on which carbon atom? On the second carbon atom. Therefore, it is 2-methyl but 1 in. You just join this to this to this. So it is 2-methyl but 1 in. Next one, class, identify the longest continuous carbon chain. So we have 1, 2, 3, 4. Here we have 1, 2, 3. Therefore, we go with 4, which is a but. But the double bond is on the second carbon atom. 1, 2. 1, 2, 3, 4. It's on the second carbon atom. Therefore, it is but 2 in. Then, anything outside that longest continuous chain is a branch. This is a methyl branch. And the methyl branch is again on the second carbon atom. Therefore, it is 2-methyl but 2 in. Lastly, class, identify the longest continuous chain. 1, 2, 3, 4 or 1, 2, 3, 4. So the longest continuous chain is a but. But the double bond is on the first carbon atom. So it is but 1 in. Although there is a branch, anything else outside The longest continuous chain is a branch. The branch has 1 carbon atom, 3 hydrogen atoms less 1. Therefore, it is a methyl branch. But when it is a methyl branch, it is on which carbon atom? 1, 2, 3, 4. It is on the 4th carbon atom. It is on the 3rd carbon atom. Therefore, it is 3 methyl but 1 in. Class, this is very, very simple. So we have that, class, as our isomers. And today is an interactive class. As you can see, I want to check from my phone, class. I can see some of my students are very attentive. I can see Anne Joroge has a pen and a paper, very attentive. Senior Times, Masese Bosibori, Flora, Roman. I can see Mutula Kilonzo following. Wow, I can see Baba, Raila Amolo Odinga following. This is interesting. Baba, we must ensure that our students pass. I can see Elisha Odhiambo. I can see Jobson Otieno. I can see Martha. I can see my wife Freda is also following. You can see you are very loyal and submissive. Thank you. So I urge you, class, to be attentive. Just hang on my lips. Give me your ears and you will enjoy your class. The next part, we are going to reactions. Okay, before we go to reactions, we will go to laboratory preparation. We go to laboratory preparation of alkenes. In laboratory preparation or lab preparation of alkenes, we have alcohol CnH2n plus 1 OH. When it reacts in the presence of conch sulfuric acid and a temperature of 170 degrees Celsius to around 180 degrees Celsius, what do we get? We get an alkene plus water. In this reaction, conch sulfuric acid, this process is called dehydration. It acts as a dehydrating agent. Dehydration means removal of water. So it only removes the OH and 1H here. It removes the OH and 1H. So the 2H and O forms water. Then an alkene, we get it from that. So if we can draw the structure of this, this is a round bottom flask. There is a thermometer. And this is a cork. So we have that. A tripod stand. We have that. A cork. So this excuse my drawing, it may not be very accurate because I don't have a ruler here. And then here we have a trough, water trough. Yes. So this is water. And then we have bubbles here. So I want to name our structure. This is heat. So class, pay attention. I want to explain this diagram, what happens. There's reaction taking place here. So this is a thermometer. That is our thermometer, measures the temperature between 170 degrees Celsius to 180 degrees Celsius. And then here we have conch sulfuric acid, and then a mixture of conch sulfuric acid, and then a mixture conch sulfuric acid plus an alcohol. Then here we have conch sodium hydroxide. Here we have an alkene gas. This is water. This is a trough, water trough. This is a gas jar. Then this is a beehive. So class, concentrate here. I want to explain to you what happens on this figure, on this diagram. This is a round bottom flask. So first, this is an alcohol mixed with conch sulfuric acid. Dehydration process takes place. During the dehydration process, excess heat is produced. That excess heat is absorbed by sand. This is sand. Because the reaction is an exothermic reaction. In an exothermic reaction, heat is produced. In an endothermic reaction, heat is produced within. It is absorbed, not produced. Endothermic reaction, heat is absorbed. Exothermic reaction, heat is produced. So the process, when alcohol is mixed with conch sulfuric acid, heat is produced. That excess heat is absorbed by sand. Then we have heating here. This heating, we have a thermometer. The thermometer ensures that the temperature does not go below 170 degrees Celsius to 180 degrees Celsius. Because if the temperature goes to 140 degrees Celsius, class, be attentive. If the temperature goes below 140 degrees Celsius, then we will produce ethers. Yet we want to produce alkenes. At 140 degrees Celsius and below, we will produce ethers. So that is the reason why we have the thermometer to control, to ensure that we have our exact temperature at 170 to 180 degrees Celsius. Then during the process of the reaction of heating and this reaction, some carbon dioxide gas may be produced. That carbon dioxide gas is absorbed in using conch sodium hydroxide. So the function of the sodium hydroxide here, conch sodium hydroxide, is to absorb any carbon dioxide produced here. Then after that, we have our gas is going to be collected underwater. Why is it collected underwater? Because the gas, the alkenes, are insoluble in water. They do not dissolve in water. Therefore, they are produced under water. So here we will have our alkene gas. So if we want to produce ethene from alcohol, we will use ethanol. So when we use ethanol, we will produce ethene gas. When ethanol is dehydrated, is hydrated, hydration process, when ethanol is hydrated, we get ethene. When propanol is hydrated using conch sulfuric acid, we get propene. So from here we can get an equation of C2H5OH. This is an ethanol in the presence of conch sulfuric acid. Then we have temperature of 170 degrees C to 180 degrees C. We get C2H4, which is ethene, plus water, because water is removed. Hydration. So that is our equation. That has blotted so much. We use the next paper. So class, from here, we proceed to physical properties. Physical properties of alkenes. Now, the first physical property of alkenes is that ethene, propene, and butene, these are gases. They are gaseous at room temperature and pressure. Then number two, ethene, propene, and butene are gaseous at room temperature and pressure. Then we have pentene and hexene are liquids at room temperature and pressure. Then another property is that the longer the chain, the higher the boiling point and the melting point. So as you go high from ethene to propene to butene to pentene to hexene, the boiling point and the melting point of the compounds increases. Therefore, the longer the chain, the longer the boiling point, and the higher the boiling point and the higher the melting point. So melting point and boiling point increases with an increase in the number of chains. Class, we are done with the physical. There are other physical properties that you can add, but these are the main ones. Next, class, we go to chemical properties. Chemical properties. Today, our lesson will be very short. Chemical properties of alkenes. So in chemical properties, we have reactions. So reaction with hydrogen. When we want to subject alkenes to react with hydrogen, they react by a process called additional reaction. This is additional reaction. They react by adding. So the first one, with hydrogen, we have an ethene reacting with hydrogen. We have hydrogen. This hydrogen forms hydrogen and hydrogen bond. But when they react, there is a catalyst. They react in the presence of a catalyst. The catalyst speeds up the rate of a reaction. The catalyst is nickel. Nickel catalyst or nickel, depending on where you come from. Nickel catalyst. Then another condition, at a temperature of 200 degrees, the temperature is 200 degrees Celsius. Then at a pressure of 150 atmosphere. So these are the conditions required. This can come in examination. You can be given this equation, then you are told, you are asked which conditions does this react. Under catalyst called nickel, temperature of 200 degrees C, and pressure of 150 atmosphere. So what does it form when it reacts? What you do, when alkenes react, they react by breaking bonds. So just break the bond. Just maintain the number of carbon atoms, then break the bond. So when you break the bond, insert the 4 hydrogen atoms that you had. 1, 2, 3, 4. Then these 2 hydrogen atoms just fixes on the first carbon atom and on the next carbon atom that has the double bond that has broken. So they fix here and here. So class, when they react this way, you have an ethene. Which compound is this? C2H6. This is an ethane. This is ethane. So we have ethene and we have ethane. So when you add hydrogen, to ethene, you get ethane. So from ethene is unsaturated, but ethane is saturated. So when you have unsaturated alkene, you add hydrogen, you get a saturated ethane. Next class, we can just do it here, sorry. Let's deal with propene. So we have propene. Propene, you add hydrogen atoms, hydrogen and hydrogen bond. That is covalent bonding, nonmetals. I told you just maintain the number of carbon atoms. Then fix the hydrogen that we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. You can see when it breaks a bond, we have 2 remaining, which is occupied by the hydrogen atom here and hydrogen atom here. Therefore, propene, you add hydrogen to it, you get a propane. So alkenes, when you take alkenes, you add hydrogen, you get alkanes. A process called hydrogenation. The process of this reaction is called hydrogenation. Addition of hydrogen. Class, mwalimu wenyu ameiva sana. Na mtaiva venye mwalimu ameiva hivi. This time round, our students must pass. Next, let me write on a clean one. So reaction with halogens. Number 2, reaction with halogens. Halogens are chlorine, fluorine, bromine, and iodine. These are the halogens. So class, the same process. The reaction is by addition. The process is called halogenation. Halogenation. Addition of halogens to alkenes is called halogenation. So in this process, we have again ethene. You add chlorine. So in chlorine, we have chlorine and chlorine bond. Then what do we get? Fix the number of hydrogen atoms, 1, 2, 3, 4. 1, 2, 3, 4. Then chlorine will take the 2 spaces where there were double bonds that has broken. So this is ethene. Ethene, you add chlorine through a process called halogenation, because it is a halogen. What do you get? What do you get here, class? 1, 2. This chlorine is on the first carbon atom, then this chlorine on the second carbon atom. So you get 1, 2 dichloro. 1, 2 dichloro ethane. 1, 2 dichloroethane. What about we try with another one, which is propene. So when propene reacts with bromine, what do we get? Fix the hydrogen atoms, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 6. 1, 2, 3, 4, 5, 6. So there are 6. Then in the 2 remaining where the bond breaks, we have bromine and bromine. So they just join where the bond breaks. Therefore, if they join, when you name it, longest continuous chain is propane. Then bromine is on the first carbon atom, another bromine on the second carbon atom. Then there are 2, it is di, then it is bromo. 1, 2 di bromo propane. It's very easy, class. Very easy. Then the next reaction with hydrogen halides. The hydrogen halides that we have are HCl, hydrogen fluoride, hydrogen bromide, hydrogen iodide. These are called hydrogen halides. That is hydrogen chloride, hydrogen fluoride, hydrogen bromide, and hydrogen halide. So when we take our first example, ethene, reacting with hydrogen chloride, what do we get? Number 1, you open it when they react. So how many are these? 1, 2, 3, 4. Just write the 4. Then on the 2 carbon atoms, we have hydrogen and chloride forming a covalent bond there. So hydrogen attaches itself here and chlorine attaches itself there. So from this, how do we name this? 1, 2, then 1, 2, 3, 4, 5. Then we have a chlorine here. So how do you name this? This is a chloroethane. Chloroethane. Now we do one more with propene. We were doing ethene and propene. So with propene, so class, in this, when you add hydrogen chloride, that is hydrogen and chlorine, what do we get? Pay attention here, class. Just write your structure here. Then fix the number of hydrogen atoms that are here. 1, 2, 3, 4, 5, 6. So we have 1, 2, 3, 4, 5, 6. Class, be attentive. So in this, where do we fix hydrogen and where do we fix chlorine? So in fixing this, we use a rule called the Markov rule. Markov rule. Markov rule. The Markov rule states that, write it down, class. Markov rule states that hydrogen atom is added to the carbon atom with the highest number of hydrogen atoms in the product or in the compound formed. Class, repeat. Kindly write this again. Markov rule states that hydrogen atom, this hydrogen atom, is added on the carbon atom with the highest number of hydrogen atoms. Okay? So this is where we say, even in the Bible, they say that those who have in plenty, more shall be added unto you. And those who lack, those who have little, even the little that you have, shall be taken away from you. And you saw classes, by the way, I know you also watch news, you also know politics. People like Murkomen who had little, the little they had was taken away from them. And today you saw again, the little that Kindiki had was taken away from him. So Markov rule, hydrogen atom is added to the carbon atom with the highest number of hydrogen atoms. So in our equation, this is the carbon atom with 2 hydrogen atoms. This carbon atom only has 1 hydrogen atom. Therefore, the hydrogen atom will be added on this carbon atom. So therefore, this hydrogen will be added on the first carbon atom. Then chlorine will be added on the second carbon atom. So how do we name this, class? Just identify the longest continuous chain, which is 1, 2, 3, which is a propane. Then chlorine is on 1, 2, 3. Chlorine is on the second carbon atom. Therefore, it is 2 chloropropane. 2 chloropropane. Class, this lesson is very, very interesting. I hope you are enjoying. We are almost through. We are almost through. Next is reaction or addition of water in the presence of conch sulfuric acid. Addition of water in the presence of conc sulfuric acid. So if we have our ethene, then this process will take 2 stages. So stage 1, you add conc sulfuric acid, and in this stage when you add conc sulfuric acid, what do you get? So conc sulfuric acid, we have hydrogen and hydrogen sulfate. Pay attention, class. Then from here, how many hydrogen? 1, 2, 3, 4. We have 4 hydrogens. 1, 2, 3, 4. 4 hydrogen. Then this hydrogen will attach itself here. Then hydrogen sulfate will attach itself here. So how do we name this compound? The compound has 2 carbon atoms. Then it has 1, 2, 3, 4, 5 hydrogen atoms less 1. Therefore, it is an ethyl group, an alkyl group. But which alkyl group? An ethyl group, because it has 2 carbon atoms, 5 hydrogen atoms less 1. So it is an ethyl. That one we've named this. Then now we name this ethyl hydrogen sulfate. Class, this is stage 1. Stage 2, we have ethyl hydrogen sulfate, this compound. This compound, when you add water, water has hydrogen and hydroxyl, or the OH group. The OH group, what do we get? One, two, 3, 4, 5. Okay, so you fix them. 1, 2, 3, 4, 5. Then class, be attentive. From here, we have the OH group. The OH group will fix itself here. Then we will have hydrogen remaining, because we cannot fix hydrogen anywhere here. Therefore, the hydrogen of ethyl hydrogen sulfate reacting with water in the presence of conc sulfuric acid, we have hydrogen and hydroxyl, or the OH group. When you break the bond, from here we said it is additional reaction. So just draw the 2 carbon atoms, then fix the 1, 2, 3, 4, 5 hydrogen atoms. That is 1, 2, 3, 4, 5. Therefore, in this, what takes its space? Hydroxyl, or the OH group, will take its space here. Then it will remain floating, reacts with water to form the conc sulfuric acid. Therefore, when you react alkenes or ethene with water in the presence of conc sulfuric acid, you form this compound. What is the name of this compound? This is ethanol. That is ethanol, class. You get ethanol plus conc sulfuric acid. Therefore, the conc sulfuric acid was acting in this reaction as a catalyst. Therefore, this was reacting as a catalyst. Very, very interesting. We are almost through, class. In the next few minutes, we'll be done. And just a little concentration. Next, we have reaction of ethene with water in the presence of acidified acidified oxidizing agent. Reaction of ethene with water in the presence of acidified oxidizing agent. The oxidizing agents that we know are: 1, potassium dichromate. Potassium dichromate. And 2, potassium permanganate. Potassium permanganate. So, class, be careful here. We want to write the equation. That is our ethene reacts with water in the presence of acidified oxidizing agent is represented by that. Then the arrow, you write H plus. H positive means acidified. Then this is the oxidizing agent. Then here we have hydrogen and OH group, OH bond. Now, what do we get from here? Class, be attentive. Just break the bond. Then fix the number of hydrogen atoms. 1, 2, 3, 4. 1, 2, 3, 4. Then we have where the bond breaks. We want to know what do we fix there. First of all, we will fix the OH group in one of them. Then we have hydrogen remaining here. This hydrogen combines with this oxygen, which is an oxidizing agent. It is oxidized. When the hydrogen is oxidized, we will get the hydroxyl. When they combine, you get the OH. And then we have our compound. So how do we name our compound? This compound, because it has 2 carbon atoms, that is an ethane. Then OH group is on the first carbon atom. Another OH group is on the second carbon atom. Then there are 2 diol. So this compound is called ethane 1,2-diol. Class, we almost finishing. Hii isikufanye uchome shule. This is very easy. Extremely easy. You just need concentration and just follow it. Class, in the next few minutes we are finishing, like 5 minutes to 10 minutes. Now, we want to go to combustion. Okay, before we go to combustion, we go to reaction with self. Reaction with self. A process called polymerization. Polymerization. You can say polymerization or polymerization, depending on where you came from. If you came from America, you say polymerization. If you came from UK, you say polymerization. So that depends on how also you are brought up. We Luos, we can also say polymerization, but you know it is shown. So in this, again we will have an ethene plus another ethene an ethene plus an ethene. This is a monomer. Monomer and a monomer gives you a polymer. But which polymer? Monomer means one. Another monomer means one. Gives you poly, means many. Mono means one. Monogamous. Monogamous. Polymer means many. Polyandry. Polygamous. Polytechnic. Poly, many. Therefore, many monomers forms polymers. A process called polymerization or polymerization. So in this process, an ethene reacting with an ethene, you do that. Then you put N here. This N means that there are many monomers before reaction, before. Then after reacting, they will form what? When they react, they break the bonds. This is the first one. Then you add to the second one. Then you bring N here. After chemical reaction, before chemical reaction, after chemical reaction. This is called polyethene. When ethene and ethene reacts, they form polyethene. When we do, let's try propene. Let's try propene. So this reacts with another one. One, two, three, four, 2, 3. 4, 1, 2, 3, 4. Okay, good. So when these two, 1, 2, 3, 4. So this, you put N here, means before the chemical reaction. Then what polymer does it give you? You open this up. It gives you this with N here. So propene under propene gives you polypropene. You have to be careful here. This one means that we've left it. We've left it to attach itself with other propene. So this gives you polypropene. So let's see if the bonds are correctly placed here. Carbon 1, 2, 3, 4. Then carbon 1, 2, 3, 4. And 1, 2, 3, 4. 1, 2, 3, 4. Good. This is polymerization. Class, lastly, and I'll give you an assignment after this, so you must take the assignment down to summarize everything that we've done. The combustion of ethene or combustion of alkenes. So we take ethene. So when you take an ethene, C2H4, you combustion, you burn in excess oxygen, you get carbon dioxide and water. The same thing alkenes. When you burn them in excess oxygen, you get carbon dioxide and water. So if we balance this equation, 2 hydrogen atoms, 4 hydrogen atoms, so we put here 2 to get 4 hydrogen atoms, 4 hydrogen atoms. Then carbon are 2, carbon is 1 here, so you place 2 there to give you 2 carbon atoms. Then oxygen is 2 times 2 is 4, plus 2 times 1 is 2, so 4 plus 2 is 6, and here we have 2, therefore you add 3 here. Then they are all, these are gases and this is liquid. So class, after that we go to uses of ethene. The first use of ethene helps in the ripening of fruits. The fruits that we have, if you subject it to ethene gas, it will ripen. Number 2, manufacture of polymers. So in this case, it is polyethylene. Polyethylene is the polythene, the paper bag that you use, the paper bag that was burnt, because they are non-biodegradable. Lastly is an assignment class. An assignment, write this down. If we have ethene, what do we do to ethene to get an ethanol? You get that? Then on this side, and mostly in exams, this summarizes everything that we've done, and this is likely to come in your examination. Again, here we have ethanol. What do we do to ethanol? What are the conditions subjected to ethanol to get ethene? Then here, if we have hydrogen, when we take ethene and we add hydrogen, what do we get? Then again, ethene, when you add hydrogen halide, which is hydrogen chloride, what do we get? Then here, when we have ethene, we add water to it in the presence of acidified potassium dichromate. What do we get? Again, here, when we burn it in excess oxygen, what do we get? And again, name this process. Name process. Then again here, when we add bromine, what do we get? Process called halogenation. So again, the product that we form here, what do we add here to get this? Or rather, if we add oxygen, if we burn it in oxygen, what do we get here again? So class, this is the end of our class. This is your assignment, and I would like to thank you very much for listening, for taking notes. And what I can see here, class, I can see people are very attentive. We have Edith Motuka, thank you for being with us. Rollins Oji. We have Mike Sonko. We have Oscar Sudi. Hey, clap for Oscar Sudi. This one is going to be a new beginning. And we have Ezekiel Mutua, Opio Clio, Kegan Kirugo, Eric Mutinda, Mutai Ken, Koech Nelson, Nora Kerich, Shiku Tilweiga. Asanteni sana. I love you all. God bless you. God bless you. My Instagram fans. On Instagram, we have I am Abedi, we have Soshi, we have Brian Kim, we have Emmanuel, we have Katrina, we have Kalius, Brian Beggy, Slick Gadgets. Thank you guys. We are together. Kazi Kosawa on YouTube. Joshua Bosire, Kudos. Sharon Perez, Kasim Katana, Tessie Abade, Omar Musa, Muhammad Ali Mwangare, we have Wanjiku Shiro, we have Stephen Ondieki, we have Jonte Mjanja, we have Abdi, Eriko, Young CEO Kenya, Leonard Kelvin, Nancy Andeyo, Felix Gashagwa, we have Mureithi Stephen, we have Philip Okeyo, Teddy Okech, Munene, Louis Odhiambo, we have Koech, thank you guys, thank you. You can subscribe. My YouTube is Babu Owino TV, Instagram is Babu Owino, Facebook is Babu Owino. Thank you all. God bless you. Kindly subscribe. TB, man, to my candidates, I will ensure that you pass exams. Just stick with me. To our parents, just lend me your children. Give them time. Whatever you can give them, the gadgets, the airtime, give them. I will ensure that they remove you from the slums. I will ensure that they raise you from where you are, because I know how much you struggle as a parent. Having gone through all this process in the slums, I know what it takes, and I will change your lives. Thank you. God bless you all. Thank you.